Today in this lecture we will discuss in more detail about the classification of the solids. So let's start this lecture from the scratch. First question is arise that what is solid state physics? So this is actually the branch of the physics in which we study the physical properties of the solids. Why we study the solid state physics? So we study this in order to answer this question. What makes steel hard, lead soft, iron magnetic, copper a good conductor? So this is actually the steel, which is a hard material, and this is the soft lead, which can be converted into any shape and it can be bent. Here this is the iron pieces and it can be attracted by the magnet. So this is actually the copper conducting wire. So what is the physics behind their hardness, their softness, or their magnetic nature and conducting nature of the materials? These properties, all properties, depend upon the structure, bonding, and particular ordering. To understand the diverse behavior of the solid, their mechanical, magnetic, optical, metallurgical property, we need a crystal structure analysis. In order to understand the physics behind this sort of material, we need to know the structure, the crystal structure analysis of these materials. So these crystal analysis is performed by X-ray diffraction techniques, which is used for crystal structure analysis. This make it possible to design a material with new and desired properties of use in modern technologies. If we know the internal structure, the bonding, or the particular ordering of the particles or the atoms, ion, or molecule inside these material, we can synthesize these material according to our desire. Okay, the solids are classified into these three parts. Okay, so first one is the crystalline solid, the other one is the amorphous solid, and the other one is the polycrystalline. Here these sodium and chlorine are arranged in a specific order, not in random form. It forms such like crystal structure. So we call this sort of the solid material is called crystalline solids. So crystalline solid are those which have a regular arrangement of the particles. That particles may be atoms, ions, or molecules, which arrange in a regular 3D pattern and constant throughout the crystal, and their arrangement, these particles are arranged in three-dimensional pattern, and this arrangement is constant throughout the crystal. So here it make a plane of this crystal, and this is the other plane, and here the distance between these two particles and the distance between these planes are same throughout. So we call this sort of the solid as a crystalline solid. These orders are repeated up to some distance, and after that their ordering may be disturbed. So the ordering of these material up to some distance is called the short range order. And on the other hand, if these material are arranged throughout the crystal, we call them as a long range order. So crystal have smooth faces and straight edges. This crystal actually have, this is actually the one face of this crystal. This is actually the one face of this crystal. This right, on this right side we have the other face, on that left side we have the other face, and on back side we have the other face, on the lower side and top side we have these faces. So these faces actually the smooth faces. Okay, and here these are the edges, okay, which separate the two faces from each other, and these are the straight edges. In the crystalline solids, these faces are the smooth and the edges are the straight. When a crystal is broken, it leave in a certain direction. Okay, so if we break this crystal, it will break at a certain direction, not in random direction. They have definite melting point. It means that if it reach its melting point suddenly, it will be melt. Particles of the crystal can vibrate about their mean position due to the provided temperatures. Example in metals are the copper and zinc. In ionic compound that are in a Cl, the sodium chloride. This is the arrangement of the particles of the sodium chloride, which is the example of the crystalline solid. Now, what is polycrystalline solid? As we have discussed, these particles may be arranged up to in a specific order up to some distance, and after that distance, it will lose their pattern. So due to that reason, due to that defects, the concept of the polycrystalline solids come into picture. So now, what is polycrystalline solid? Polycrystalline is a material made up of many small single crystals, are called the grains or domains. Okay, there are some materials which are called the polycrystalline solids, in which the arrangement of the particle in a specific order are present up to some distance. So after this distance, this arrangement is varying. Okay, so up to this distance, the arrangement is same. We call them as a small crystal. Now this is the other small crystal, this is the other small crystal, this is the other small crystal, and we call this small crystal as a what we can say as a grain. Okay, so we call them as a grain. We also call them as a domain. So the specific arrangement of the atoms in this particular region, which form the two-dimension or three-dimension space, we call that space as a grain or domain. This one domain and this is the other domain. These two domains are separated by this boundary. Okay, this is actually that boundary, and we call this boundary as a grain boundary. This is actually the grain boundary, because it separate two grains from each other. Here is that same grain. These dots are actually the atoms. Okay, these atoms are arranged in a specific order within the grain or domain, but when after that grain boundary, that order has changed, and inside the other domain we have a specific ordering of the particles. Now this is the 3D view of that polycrystalline solids, and if we cut them vertically, it will give us such like shape. And here, this is the one domain, this is actually the other domain, and these domains are separated by the grain boundaries. Okay, and here if we cut this three-dimension structure as horizontal, okay, it will give us this like shape. In this simulation, the different color represent the different domain in 3D form. Okay, so here within the grain or the domain, the particles, by particles I mean the atoms and or molecules, which form this small crystal within the polycrystalline solid will be in a particular order. Okay, so the this is the one small crystal, this is the other small crystal, and here within this crystal the atoms, the particles are in a specific order, and here this is also in a specific order. Okay, and this is their same simulations. Okay, this is the 2D and this is the 3D view of that. This grain having the size varying from 10 power 3 angstrom to 10 power 4 angstrom. These grains separated by the grain boundaries. The atomic order can vary from one domain to the next domain. Each grain is of irregular shape and varying in size with respect to one another. These shapes are irregular. Okay, it is irregular shape, and their size is varying. One is the small domain, the other one is the large one. Okay, and we call them this domain is a grain, and here between the two grain we have the grain boundary. Polycrystalline material are isotropic and exhibit the same property along all directions. The particles inside these polycrystalline materials are arranged in every direction. So therefore the polycrystalline material have the same properties along all directions. The example of polycrystalline solid is PVC, polyvinyl chloride, or polyethylene. Now what is amorphous solid? Amorphous solids are composed of the random oriented atoms, ions, or molecules. They do not form a definite pattern. So this is actually the amorphous solid in which the atoms do not make a specific pattern. They do not arrange in a specific order. So these particles are randomly oriented, are randomly arranged. So we call this this substance, this particle is a amorphous. This sort of the solid is called the amorphous solid. The example of the amorphous solid is the glass, rubber. Inside that rubber, the particles are arranged in this way, not in a specific order. The word amorphous meaning without structures. This sort of the material amorphous solid can be formed by rapidly cool the molten material. So rapid cooling of the metal from the molten state cause amorphous solid. If we convert the copper into molten state by providing a large heat, and if we suddenly cool that copper metal, okay, so the copper metal is good conductor. If we perform this operation on that good conductor will be converted into amorphous solid, and that their conducting behavior will be lost, and that will become insulator. Okay, now what does mean by undercooled liquid? Some liquids exist in nature. When we cool that, it become more viscous and then rigid. Okay, the retaining the random arrangement of the particle is called undercooled liquids. Some sort of the liquids which are present in this nature, if we cool them, they become viscous, and the atoms are arranged in random form. Okay, and there is random arrangement of the particle, and we call them as a undercooled liquid. The property of the amorphous solid include the no sharp melting point. It means that if it reach its melting point, or the temperature in which this material is be melt, so this material as a whole do not melt at that specific temperature, melting point temperature, just like on the other hand we have the crystalline material. That crystalline material abruptly and suddenly melt at that melting point, and here this amorphous solid do not melt at the melting point. suddenly. Example of the amorphous solid are the glasses, rubber, glue, and polymers. Now, what does mean by the unit cell? As we see in case of the crystalline side, we have the NaCl crystal. Inside that, we have the specific pattern inside the crystal, which is repeating in all directions. Okay, we call them that specific pattern as a unit cell. So here, this blue color region inside this crystal structure is called the unit cell, and this unit cell is repeated in this side, it has repeated on that back side, on this top. Okay, and if we extend this crystal in this side, so here on this left side, this unit cell, this specific pattern is labeled here as a blue color, will be repeated in all side from itself. Okay, so we call this specific arrangement, this box like shape, or this square as a unit cell, because this is repeating in all directions. So a unit cell is in a crystalline solid consists of the three-dimensional pattern that repeat itself over and over again. This smallest three-dimensional basic structure is called the unit cell. Now, what is the space lattice? A space lattice is a regular periodic arrangement of the points in a three-dimensional space such that each point is having identical surrounding as that of the other is called the space lattice. So here this is actually the space lattice in which these all points are arranged in a specific order in three-dimensional space. Okay, and they have the identical surrounding, and atoms are a group of atoms identical in composition, orientation, and arrangement, which when arranged on the point of the space lattice in a regular periodic manner generate the complete crystal structure. So here we have the space lattice, and at these sites, okay, at these points, if we put the atoms ion or molecule, so that atoms ion or molecule is called the basis. Okay, that basis must be in the same orientation. So what is the crystal structure? Crystal structure is made by the space lattice plus the basis. This is actually the space lattice, the framework. Okay, so here in this framework, the each particle, instead of these sides, we put the basis. So here this red color is representing the basis. So if we put that basis is these points, so it become this. Now this structure is actually the combination of this space lattice and this basis, so we call them as a crystal structure. Crystal structure is formed by the space lattice plus the basis. And this is the other example, and here if we have molecule, this is actually the atom, and these are the atoms, molecules. Okay, so if we have molecule and if we put that in these points, okay, it will give us this arrangement. We call them as a crystal structure. Now, what is the lattice site? The point which are forming a lattice is called the lattice sites. So these are the lattice sites. So we call these sites as a lattice site in which the atoms ion or molecule will be can be fit. So that site is called the lattice sites. Now, what is lattice constant? The distance between the consecutive neighbor sites is called the lattice constant. So here the distance between this lattice site and this lattice site is called the lattice constant, and it is represented by A, B, and C. A for the x-axis, B for the y-axis, Z and C for the z-axis. When we assign direction to these lattice constant, they become lattice translational vector. So here we have, this is the actually lattice constant A, and this is on the x-axis. On the y-axis we have the B, and the z-axis we have, this is actually the y-axis, and this is the z-axis. So these are actually represented by these lattice constant. Okay, and this is the lattice side, this is also the lattice side, this is the lattice sides. Okay, and these are the lattice translational vectors. So this was the explanation about the polycrystalline, crystalline, and amorphous solids. So these all explanation was from my side, and that's it guys. Thanks for watching.